June 2015, Part 3. Each question is worth 4 points. Number 33. Albert says that two systems of equations shown below have the same solutions. Determine and state whether you agree with Albert. Justify your answer. So you have two systems of equations, and there's two ways in which to solve for these problems. However, for either one of the methods, you still have to solve each equation for y. So whether you do it algebraically or you do it graphically, you need to solve each equation for y. Now I know that these two are the same, so I only have to solve it once. So I'm going to go ahead and write it off to the side here. And since I'm solving for y, I'm going to move the 8x. And I get 9y is equal to 48 minus 8x. And divide out the 9. And I get y is equal to 48 minus 8x over 9. I'm going to write that on this side too, because it's the same thing. Then for the second equation, 12x plus 5y is equal to 21. I'm going to solve that for y. So subtract 12x from both sides. And I get 5y is equal to 21 minus 12x. Divide out the 5. So algebraically, you would take these two and set them equal to each other. And cross multiply. Or simply put the two equations into a graphing calculator and see if you get the same points of intersection. So if you get a common solution, then we know that Albert is correct. So I'm just going to quickly jump over to this right here. I need to solve for y, so I'm going to divide out the 8.5, or the negative 8.5, that is. So y is equal to negative 51. Oh, it's going to become positive as a result. So let me go back. A negative divided by a negative is positive. So 51 over 8.5. And then you said these two, 48 minus 8x over 9, equal to each other if you don't do this graphically. And then you cross multiply these as well. So we get 8.5 times 48 minus 8x is equal to 9 times 51. So we distribute the 5 and we get 5 times 48 is 240 minus 8 times 5 is 40x is equal to 9 times 21 is 189 times negative 12x, 108x. Now we're going to go ahead and solve for x. So we're going to get the like terms together. I'm going to subtract 184 from 240 and add 40x to both sides. We get 56 over here, and that's equal to a difference of negative 68x, and we divide out negative 68. And we get x is equal to negative 0.82. So after doing all the work, I went ahead and distributed and used inverse operations to find my value of x. As you can see, we get the same exact values. And if you go ahead and substitute this value into any one of these equations, and I would do one from each, you're going to get the same y value. So do your substitution, or better yet, just go and graph them, and you'll see that they all have a common point of intersection. So Albert is correct, and the reason as to why is because they all have the same common point of intersection. The equation to determine the weekly earnings of an employee at the Hamburger Shack is given by W of X, where X is the number of hours worked. So the first thing you should recognize is that you have a piecewise function, and that means you have two equations which are given, and here are the constraints for the domains. Determine the difference in salary in dollars for an employee who works 52 hours versus one who works 32. So since 52 hours is greater than 40, I'm going to substitute that into the second equation, 15 times x minus 40 plus 400. Substitute 52 in for x and do the math. We get 580. On the other hand, a person who works 38 hours applies to this interval here. It's less than 40 but greater than 0, so I'm going to plug it into 10x, which is equal to 10 times 38, which is equal to 380. So the difference is 580, take away 380, which is equal to 200. So that's the difference in salary. Determine the number of hours an employee must work in order to earn $445. Explain how you arrived at the answer. So the way in which I tried to figure this out is I set each of these equal to 445 in order to solve for x, and I looked at the one that fits the domain constraints, and that's the one I selected. So I have to use both of the equations in order to solve for x. So here's the first one. So I get 15x minus 600 plus 400 is equal to 445. Combine like terms, so negative 600 plus 400 gives us a difference of negative 200, and that's equal to 445. Add the 200 to both sides to get a sum of 645 and divide by 15. So x is equal to 43. Now the other side. We will set 10x equal to 445, divide by 10, and get x is equal to 44.5. So since both values come out to be greater than 40, I'm going to reject this one here because we got to go with the constraint that, the domain constraint that's greater than 40. So it's 43 hours that an employee must work in order to earn $445. Number 35. An online electronics store must sell at least $2,500 worth of printers. Keyword at least. So that means $2,500 or more, so that's greater than or equal to. Worth of printers and computers per day. Each printer costs $50 and each computer costs $500. The store can ship a maximum of 15 items per day. So that means it's 15 items or less, so it's less than or equal to. Simple. So on the set of axes below, graph a system of inequalities that models these constraints. So I have two inequalities in terms of cost, and this is one total. And I also have one in terms of items, which is the other inequality. So in terms of cost, each printer costs $50 and each computer costs $500. I'm going to let each printer be X and each computer be Y. So in terms of cost, we have 50 times x plus 500 times y is less than, nope, greater than or equal to 2,500. And in terms of items, we have x plus y is less than or equal to 15. So I have to solve each inequality in terms of y. So this is y is less than or equal to 15 minus x, where 15 is the y-intercept, and negative 1 over 1 times x, so negative 1 over 1 is your slope. And over here, we get 500y is greater than or equal to 2,500 minus 50x, and divide by 500 to get y by itself. And we get y is greater than or equal to 2,500 minus 50x over 500. So I would put this into your graphing calculator, and you could either do it simultaneously or independently. Look at the table of values and go ahead and graph each of these lines. So I chose to graph them simultaneously, and here is the table for both of them together. So I'm going to use the nice integers in order to graph each of these, and then also shade in my areas either above the line or below the line depending on the direction of the inequality sign. So I'm going to do the first inequality first in terms of total cost. So that's these two. And then when I'm done with that, I'll do it in terms of total items, which will be these two columns. Keep in mind you have to use all positive values for x because they've already started you off here. Okay, so this starts at 0. Okay, so I've labeled my x and y values, and I'm going to go ahead and graph my points. So for the first line, I'm going to graph 0, 5, and then I will go up to 10, 4. Now you only need 2 points to graph a line, but I'm going to do one more. You use a straight edge in order to connect all your points. I don't have that ability, so I'll do the best that I can in order to draw the straightest line as possible going through all through points. So for the first one, it's all values for y are greater than or equal to this line. So all values for y greater than or equal to this line is shading above the line. As for the second line, the first point I'm going to graph is 0, 15. I'll go with 3, 12. 7, 8. 10, 5. 12, 3. Okay, so that should be enough points. And I'm going to draw a line to the best of my ability. Again, you use a straight edge like a ruler in order to connect the points. And for this one, all values for y are less than or equal to the line. So I'm shading here. So my common solution area is where they crosshatch or they overlap. So in order to determine the combination of printers and computers that would allow the electronics store to meet all of the constraints would be something from the crosshatched area. So we could go with any one of the coordinates that's in the crosshatched. So I'm going to go with 6, 6. So we can have 6 printers and 6 computers. That would allow the store to meet all the constraints. And the way in which I obtain the answer is that I picked a coordinate from the crosshatched area or the solution set that fit both criterias. Overlap, that's what this spells. OVERLAPPED. Number 36. An application developer released a new app to be downloaded. The table below gives the number of downloads for the first 4 weeks after the launch of the app. Write an exponential equation that models these data. So what I would do in order to do that, I would use the exponential regression feature on the calculator. I would put these numbers into a spreadsheet. I would label the first column WE for weeks and DOW for downloads in the second column as the title. And then hit menu for 1A. I will show that to you in a couple of pictures in a minute. Again, let me reiterate. You're going to use the spreadsheet function, which is accessible by hitting the home button and then selecting this icon down at the bottom of your screen. Enter your information from the table in the columns and label it as I had stated before, we and DOW, or you can just put X or Y if that's easier for you. Then you're going to hit menu for 1A, or you choose this right down here, exponential regression. It's going to give you the values for an exponential equation so that you can insert them in. And here are the values that you should get. This is your value for A, which goes here. And this is for your value for B, which goes there. The way to interpret this equation is A times B raised to the X power. So we want to write an exponential equation, and it looks like this. Y is equal to A times B raised to the X power. I have my value for A, which is 80. I'm going to put parentheses around the B times X, which is 1.5 raised to the X power. So the X is in the exponent. That's how we know it's exponential. And this is our answer. So using this model, we're going to predict how many downloads the developer would expect in the 26th week, so that's X, if this trend continues around your answer to the nearest download. So that means I'm substituting 26 into the equation for my value of X. I'm going to put this in the calculator exactly the way that I've written it. Be very careful with how you put this in. Make sure you put these parentheses around this base, 1.5, and then raise it to the 26th power. In order to raise it to the 26th power, you have to use the upside down V, which is over in the left column. It's a gray button below the control button. And rounded to the nearest download, we get 3,030,140 downloads. And would it be reasonable to use this model to predict the number of downloads past 1 year? Explain your reasoning. So the answer to this is no, because a new and better app would probably come out, and not as many people will download at that point in time. So as a result, apps come and go. Therefore, there will probably be a better app in 1 year. And nobody will be downloading this one anymore.